Hello guys, welcome back to another video. In today's video we will be doing exercise 4F. My apologies for last video. I did not realize y'all had not learned the power rule yet, and I may or may not have been using that when y'all should have been using first principles, but it's fine. Let's go ahead and get started with this exercise. This may or may not be a re-record, you'll never know. Okay, question number 1 asks us to find the following functions, or the derivatives of the following functions using first principles, and I'll go ahead and explain what that is real quick. After I write this out, it gives us this function, and it asks us to find the derivative at x equals 0. Okay, so I'm going to come to the side real quick. What first function states is that for any given function, the derivative of the function, that's not what that was supposed to be, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now this comes from the whole rise over run, where our rise is just going to be this little small area that's left behind whenever we get closer and closer, and the run is obviously just going to be h. Okay, so that's where that comes from, and we need to plug x plus h into here so we can actually get that going. So let's first start off by finding x plus h. And I'm going to do most of this step by step and write it legibly so you'll understand. That is a -2, right? Yeah, okay. This is just going to be equal to x squared plus 2xh plus h squared plus x plus h minus 2. Now that we have that, we can plug that back into here, and we already know what the original function is. So let's create a little thing down here. So the limit as h approaches 0 of f of x plus h, which is equal to this, so x squared plus 2xh plus x squared plus x, sorry, not x squared, wow, plus h squared plus x plus h minus 2 minus the original function, so minus x squared minus x minus 2 plus 2 divided by h. Okay, here we need to start canceling out terms. Notice that the x squareds cancel out, the x cancels out, and the -2 cancels out. This leaves us with the limit as h approaches 0 for 2xh plus h squared plus h over h. And we want to get this h out of the denominator, or else we're just dividing by 0. Here, that happens pretty easily, where we're just left with 2x plus h plus 1. Now, as h approaches 0, h is gotta be equal to 0, air quotes, because it's not actually equaling to 0, but then it's getting close enough. We can kind of just cancel that out, and we get left with the derivative equal to 2x plus 1. And it was asking us to find it at 0. Plug 0 into this, and you're just gonna end up getting 1. All right, on to B. For B, we have the function f of x is equal to 2 minus x plus 3x squared, and it's asking us to find f prime of -1. Okay, once again, let's plug x plus h into the original function so we can understand what that is. Well, know what it is since we need to know what it is. This is going to be 2 minus, our x is now x plus h plus 3 x plus h squared. And now you're just going to have to believe me whenever I simplify this in a second. So we know the derivative is going to be equal to the limit as h approaches 0 of f of x plus h, which is 2 minus x minus h plus 3x squared plus 6xh plus 3h squared. And now we have to subtract that from the original function once again. So minus 2 minus x, so plus x, and minus 3x squared. And all of this is going to be divided by h. Okay, start canceling out terms again. The 2 cancels out, negative x cancels out, and the positive 3x squared cancels out. This leaves us with negative, okay, that didn't work, negative h plus 6xh plus 3h squared over h. Let me make sure that makes sense real quick before I get too crazy. Okay. And this is all as the limit approaches h, but first let's divide out. H divides. We end up getting negative 1 plus 6x plus 3h. And as h approaches 0, that's going to cancel out. So that gives us f prime is equal to 6x minus 1. And it asks us to find it at f negative 1, which is just going to be negative 7. That is our final answer. On to 1c. We have the function f of x. Okay, I'm sorry it gets a little complicated, but it should be fine. Is that a negative 2? Yep, negative 2 divided by x, and it asks us to find f prime of 1. Okay, so once again, we're going to use first principles. As h approaches 0, we get negative 2 divided by x plus h minus 2, so plus 2 divided by x, which is just the original function, over h. Okay, first step here is we're going to need to combine like terms on the numerator. So I'm just going to come to the side here. To combine like terms, we need like denominators. So left-hand side, we're going to multiply this by x. And right-hand side, we're going to multiply this by x plus h. That ends up being x times x plus h. And let's see. Yeah, that's fine. Okay, now we're going to come back here. So now we have negative 2x plus 2x plus 2h over x times x plus h divided by h. Now, something we need to recognize here is when we have a divided by h like this, these terms, the only terms I can cancel out if there's a space stopping them like that. And the reason why is because this thing can be rewritten as this times, I'm going to use a dot for that, if it'll let me, times 1 divided by h. Because we're just dividing this entire thing by h. So we can rewrite it like that. And now if we notice something, these two x's cancel out. That leaves us with a 2h on the top. Would you look at that? That cancels out. So now we can rewrite this as the limit approaches 0 of 2 divided by x plus h. And even though we have a h at the denominator, it's not the only thing there, which means that as this approaches 0, it's going to cancel out. We're just going to get x times x, which means that our derivative is going to be f prime is equal to 2 divided by x squared, which makes sense. And we plug in 1 here to just get 2. Okay, there we go. My leg hurts. Whatever. Okay, what's next? 1D? Okay, I'm like angled really weirdly. Give me a second. But my leg hurts. Okay, whatever. 1D gives us f of x is equal to... Where'd it go? Okay, here it gets weird. What the heck? X plus 1. And we're told to find f prime at 3. Okay. Once again, using first principles, I need to stop saying that because this is starting to wear me out. We get this shenanigan. Divided by h. Okay. With these types of functions, there's something you need to recognize. What we need to do is get this h out of here, because there's no way we're going to get rid of this h without somehow getting this h out of here. To do that, we need to do a little thing called rationalizing. Now, remember, to rationalize anything that's under the square root like this, we multiply it by its conjugate. In this case, its conjugate is going to be x plus h plus 1 plus, and that's its conjugate, x plus 1. I remember anything we do to the numerator, we do to the denominator. So likewise, can this please work? Okay, my handwriting's starting to get a bit ugly. Sorry about that. Okay. Now remember how math works. This is just going to be equal to a squared minus b squared. In this case, a squared is square root of x plus h plus 1 squared. So x plus h plus 1 minus b squared, which is going to be minus x minus 1. Right? Yep. Okay. And all of this is going to be divided by h times root x plus h plus 1 plus root x plus 1. Probably going to be some nerd in the comments talking about, can we add the roots together? I don't even know. I'm losing it. Okay. Notice that once again, this cancels out, this cancels out, that cancels out. That leaves us with an h at the top by itself. And look at that. We're able to single out the h, which means that we can now cancel the numerator h out with the bottom h out. Reason why is because now we have no more variables on the top, since x and the 1 canceled out. And that leaves us with the limit as h approaches 0 of 1 divided by root x plus h plus 1 plus x plus 1. Okay, and once again, it's fine if the h is on the denominator now, since we have other terms, which means that the derivative is going to be equal to h just going to go to 0 infinitely. 1 divided by root x plus root x plus 1 plus root x plus 1, which is going to be 2 root x plus 1. And is asking us to find that at 3, was it? Okay. 3 plus 1 is 4. Root 4 is 2, so 2 times 2 is 1/4. And there we go. On to the last two. We now have the function for e. Let me put a dot right there. 1 divided by, why does it just get harder? square root of x, and it's asking us to find this at f prime 9. Okay. Rewriting this as first principles. We're going to get 1 divided by, that's 1 big divided by sign, root x plus h minus 1 divided by root x over h. And once again, let's start off with the numerator. First thing we need to do is combine like terms. So multiply the left. My foot, damn. Give me a second. I got a notification. Okay. Oh, okay, never mind. I'm not saying like that anymore. Screw y'all. Oh, not screw y'all. Love y'all. Okay. That's ugly. So we multiply the left-hand side by root x, right-hand side by, excuse me, root x plus h over whatever this conglomerate of a mess is. Okay, and hey, would you look at that? We gotta work with the denominator. Once again, don't hate me. We just gotta get this h out of here so we can divide it by the last h. To that, remember what I said, multiply everything by the conjugate, which is going to be, in this case, did I write that right? Yeah. Root x plus root x plus h, and likewise on the bottom. Okay, we're going to get a really messy equation in a second, so stay with me. Remember, we're only working with the numerator so far. Okay, bringing this down, we're going to get x minus x. Did I do this right? Yep, minus h over square root x. Please stay with me. Square root x plus h times root x plus root x plus h. Okay, notice how these two cancel out and leave us with a negative on the top. We're going to bring this denominator over here. And remember, if we're just dividing like this, we're multiplying by 1 divided by h. So those cancel out. We're left with a negative 1 on the top. This means we have the final limit as h approaches 0 of negative 1 over, okay, well, time to write all this out again. Root x plus h, root x plus root x plus h. Wow, a lot of work. Okay, and as h approaches 0, those h's are going to disappear. So we end up getting f prime equal to negative 1 over root x times root x, which is just x, times root x plus root x, which is just 2 root x. Did I do that right? Right? Yeah, okay. Just making sure, sorry. And that can further be simplified as negative 1 divided by 2x root x. This, I feel like there's another way you can simplify this, but it's fine. Okay, and it asks us to find f at 9. Okay, that's just going to be negative 1 divided by 2 times 9 times root 9, which is 3, which is negative 1 over, what's that? 18 times 3, 54. There we go. Here's our answer. A lot of work. I hate first principles. Practically pointless for derivatives. No, it is pointless for derivatives, actually, once you learn how to solve them normally. But very good to know and will be useful later on for limits. Okay, last one. We're given the function f of x is equal to x cubed minus 1. Okay, they're giving an easier one this time around. Okay, so first we need to find f of x plus h. Now, to do that, there's several ways you can do it. You can use Pascal's triangle. You can just go out and multiply it by hand. Use Pascal's triangle. I actually don't know if this has been taught yet in the order of the book and whatnot, or if this is what they want you to do. But basically what Pascal's triangle is showing for any polynomial, I'm not going to fret on it too long. You kind of create a triangle like this, and in anything that's a plus b, this is how you solve it. This is 0th degree, 1st degree, 2nd, 3rd. And it's the coefficient you put on, and it descends the exponent. I'm not going to get into it too much. Just do simple math and you'll figure it out. So just believe me whenever I write this. But, okay, well, I'll just write this quick. That's x to the 3rd. It's going to be x to the 0. X to the 2nd, x to the 1st. And I can't write it out, but basically b to the 0 is going to be here. B to the 1. B to the 2. B to the 3. And you can kind of see how it's going. In this case, h is b. So we're going to come down here. Rewrite this as a limit as h approaches 0 of f of x plus h, which is going to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus 1 minus the original function, so x cubed. Let me get this out the way. Minus x cubed minus minus 1, so plus 1 over h. Okay, look at that. These x cubes cancel out. These 1s cancel out. That leaves us with 3x squared h plus 3x h squared plus h cubed divided by h. Cancel these h's out. I'm going to get left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared, which means that these two terms are just going to cancel out, and we're just going to get f prime at 3x squared. And it asks us to find f prime at 1. That's just going to be 3. Okay, on to number 2. So I'll just scroll down right here. Number 2 tells us that a particle is moving in a straight line so that its position in meters in relation to its starting point after t seconds is 8 plus 2t squared meters. Okay. What's it saying? Oh. Particle moves in a straight line so its position. Okay, so we're going to have, I forgot what position. Okay. st, we're going to use s as our like function. This is just f of t basically. But since we have an t, x is going to be t in the f of x function. And physics stuff, so position as s, you get the point. We have 8 plus 2t squared and meters. Okay. It tells us that if the particle moves through a point A, okay, so I'll just have A here, at t equals A, okay. Ignore how ugly my t is. And point B at t equals A plus h. Okay, well, look at that. I'm already starting to see a first principles rule. It's asking us to find the average velocity, which is speed, of the particle as it moves from A to B. Okay, I probably shouldn't have used s for that. But what we need to recognize is that the derivative of this function, which is just displacement, you know what, just to make it easier, I'll make this d. The derivative of displacement is going to be velocity. So recognize this. And it's asking us to find velocity. So we need to find derivative of dt. which can be found using the first principles. So let's go ahead and start that. So we're going to have the limit as t in this case, no, as h approaches 0. It said of the particle as it moves from A to B. Okay. What was I going to do? From A to B, just going to be d of t, d of A plus h, which I need to find that real quick. This is ugly. Give me a second to rewrite this. Wow. What is this lag? Okay. Okay. You know that d of A plus h is going to be equal to 8 plus A plus h squared, which is going to be written as 8 plus h squared plus 2ah plus h squared minus dt, which is going to be minus 8 minus whoops, there was a 2 in front of this. That's a bit embarrassing. Let me rewrite this. Sorry. Plus 2a squared plus 4ah plus 2h squared minus the original function, so minus 8 minus 2. It was originally 2t squared, but now that we're looking from A to B, it's going to be A instead of t. This is all going to be divided by h. These 8s end up canceling out. 2a squared cancels out. This leaves us with 4ah plus 2h squared over h. Those h's cancel out to give us the limit as h approaches 0. Of 4a plus 2h. And that's simple. The h goes away. So we're left with the derivative of displacement. So velocity, t, is going to be equal to 4a. That is our answer. B says to find the instantaneous velocity, which is just going to be speed, of the particle as it passes through point, point A. Okay, recall what we said earlier. When it passes through point A, t is going to be equal to A. Whoa, okay, quick mistake. Sorry, okay, the only mistake here was it was asking for the average velocity in, what was it? Part A. In that case, we do not take the limit as h approaches 0. We're just going to use first principles, but we're not taking any limits here at all, because that's asking for the average velocity. Part B is asking for the instantaneous velocity, which in this case, we do take the limit as h approaches 0 of vt, which is just going to be the limit as h approaches 0 in 4a plus 2h. And you can see that's going to give 4a. Okay, there we go. That's the instantaneous rate of change, or the instantaneous velocity. This is the average velocity. Okay. Sorry about that. Minor error. It's fine. 3. A particle moves alongside a straight line such as after t seconds, its displacement, so let's create a displacement function, is in s meters. What? Oh, okay. Is displacement meters is going to be blank meters. If this displacement is given by this function, 10t squared minus t cubed, find an expression for the velocity of the particle after t seconds. Okay. Just to make sure, the expression for the velocity of the particle after t seconds. Okay, in this case, we are taking the limit again. So, I don't think you'll know how badly I want to power rule this whole thing, but I won't. Once again, we're going to use first principles. We're going to find this function as h approaches 0 of dt plus h. So let me go ahead and actually solve this in a way you'll get it. We first need to solve for dt plus h. And remember the whole Pascal's triangle thing. I'm going to erase this because it's in my way. Oh, I dropped my pen. Okay, that erased everything. Why didn't... Okay. Okay, in this case, that's going to give us 10 t squared plus 20 th plus 10 h squared. Okay, bear with me now. Minus t cubed minus 3t squared h minus 3t h squared minus h cubed. Okay, now I'm going to have to rewrite this entire thing in a second. That's lovely. I'm actually going to move this down for space reasons. So the limit as h approaches 0 of dt plus h, which was 10t squared plus 20, right? Yep. Plus 20th plus 10h squared minus, did I lose myself? No. Minus t cubed minus there's a 3 in front of that. Minus 3t squared h minus 3th squared minus h cubed. And this is going to be over h. Let's start canceling out some terms. What can we cancel out? Oh, wait a minute. I forgot to subtract this from the original function. So I'm going to parentheses that so we can just recognize that that's one function of itself. Okay, so minus the original function. So minus 10t squared minus t cubed. So plus t cubed. And now we can start canceling things out. These cancel out. 10t squared. The t cubed cancel out. And that's not supposed to be like that. And I just erased it all. What else cancels? I'm struggling to find. Okay, I think that's all that cancels. Okay, so now we can rewrite this as 20th plus 10h squared minus 3t squared h minus 3th squared minus h cubed over h. And once again, all these h's cancel out to give us the derivative. In this case, it's not going to look like that since we're using displacement. Is going to be equal to the limit as h approaches 0 of 20t plus 10h minus 3t squared minus 3th minus h squared. That's cubed. Sorry. Am I forgetting how to do math? No, it's not. That's squared. I wouldn't erase now. Minus h squared. Which means that dt, that's one ugly d. d prime t is going to be equal to all those h's. This just goes away. Same with that. We get the derivative to be 20t minus 3t squared, which makes sense. That is our answer for A. On to B. B asks us to find the velocity of the particle after 1 second and after 10 seconds. And comment on what you think the signs of the velocity signify. Okay. Again, velocity is just going to be equal to the derivative of displacement. So it asks that 1 second. At 1 second, we have 20 times 1 minus 3 times 1 squared. Which is just going to be equal to 20 minus 3, which is 17. Just assume meters per second. And velocity 10 is going to be 20 times 10 minus 3 times 10 squared, which is going to be 200 minus 300, which is negative 100. Okay. In this case, with the velocity, what the sign signified, this is a positive sign, well, this one's a negative sign. This means that when t equals 1, the velocity is positive, which means that the particle is moving in a positive direction. Let's just say north in this case. However, once we get to time equals 10, the velocity is actually negative, which means that the particle is moving in the opposite direction. So, boom and boom. Okay, that's going to be all for today's video. I hope you all enjoyed. And I'll be back with... what's the letter after F? F, G. G sometime soon. What's G about, actually? Let me get some drawings in before I'm done. I like this cat. I may or may not have stolen it from someone that I like. I actually have a crush on them. I'm actually dating them. I don't know how to draw the body. Okay. Whatever. Just make this look cool. What was G about? I'm just rambling now. G's... do y'all learn any rules? Y'all are still... first principles are still being used here. This is evil. Just ask you to find the derivative, tangent stuff. Okay, I hate tangent. Okay, see ya.